Welcome to Pocket Science channel.
Hello guys, welcome to this video. We are going to continuously look through the GCE advanced level physics examination of Sri Lanka, and to kick off with it we are going to start with 2019 GCE A-level physics paper, and this will be the initial part with 10 MCQs, and we'll be continuously posting all the exam papers and all the years from if you don't have the past paper of the 2019 GCE A-level physics paper, you have the link in the description, so you can get the paper over there, and we are going to discuss those all the questions continuously. And the first question is, which of the following is not a fundamental unit? Okay guys, so this is the basic of advanced level physics, and in all the past papers you will be getting the first question under this category. So as you know, we have 7 fundamental units. Those are meter for length, kilogram for mass, seconds for time, Kelvin to measure the temperature, ampere measure the current passing through a conductor, and the next one is mole to measure the amount of substance, and finally candela for the luminous intensity. So these are the main 7 basic fundamental units we have in physics. So the answers, you have joule in second, right? So joule is not an fundamental unit. It's the unit for work, right? It's the unit for work, but this is not a fundamental unit. Joule can be written in the fundamental units. It means the work is equals to force into length, right? So force you get Newton, and for length you get meter. So joule can be written as Newton meter, and you can convert the Newton meter into kilogram meter second minus 2 also. So finally, ultimately, you can write joule as kilogram meter squared second minus 2, right? So joule can be written as this, as in fundamental units. So joule is not a fundamental unit, so the answer is second answer for the first one. And the next question, the dimensions of the gravitational constant G are given by. So when you get this kind of a question, first you have to utilize the equation that you know. So a equation well known that consists G is equation for the force in gravitational field. So that is F equals G m1 m2 over r square, right? So this is your fundamental equation what we are going to consider about. So from this I am going to take an equation for G, right? So it will be F r squared over m1 m2, right? So we know the unit for G, right? To find the unit for G, we can substitute for this one. For force, it is kilogram meter second minus 2, right? R is the radius or the distance, so R can be written as meter, so it is meter squared divided by m are defined as mass, so those gonna be kilogram into kilogram, right? So you can cut off the kilograms, and you can, that's it. So the unit for gravitational constant G will be, you have a meter cube, kilogram minus 1, and second minus 2, right? So writing this in dimensions, the dimension for meter, the length is L cube, kilogram the mass is m minus 1, and s is t time minus 2. So the dimension for gravitational constant G will be L cube m minus 1 t minus 2. So the answer is 4th. So the third question we have, when a bipolar junction transistor operates in a saturation mode, a further increase in basic current will. So this is directly from the theory. So we know that when a transistor is in a saturation mode, it is already at on position, right? So when it is in a on position, there will no any current increase in collector even though you increase the current in base. So there will be no any current increase even though you increase the current in base since the transistor is already in saturation mode. So the answer will be fifth one, right? So the next question is, according to the evidence found in particle physics, matter is composed of, right? So in the initial stage of science, they said that they can't divide atom anymore, but since the technology has improved, they have divided it more. So basically quarks are from divided by newtons. In quarks you have basically 6 types. Those are up and down, charm and strange, top and bottom, right? So basically these up and down are present normally in all the neutrons, and these 6 are called quarks. And then the leptons are normally electrons, but in addition to electrons we have 2 more. One is mount and the other one is tau, right? In addition we have their neutrino version, so they are called VE, V mu and V tau, right? So these are the 6 leptons available in fundamental physics, right? So there are totally 6 quarks and 6 leptons, so the answer is fifth. So the next question is the variation of the gravitational potential VR due to a point mass with the distance r is best represented by. So in dealing in these kind of questions, we should have a thorough understanding about the equation. So the equation for the gravitational potential with respect to r is given by, so the gravitational potential VR is given by minus Gm over r, right? So in this question they are asking the relationship between the V and R. So we can consider if it is a point mass, we can consider that mass is constant always, and also G is always constant. So the relationship between V and R is minus 1 over R, right? So these kind of graph form that is like this, right? So the answer will be second one. So the next question we have the sixth. Which of the following statement is incorrect regarding thermometry, right? So the first one is there must be a measurable physical quantity that varies with the temperature, right? So that is correct because the temperature could be measured only if you have a physical quantity that varies according to the temperature, right? So the next one is mercury glass thermometers consist of thin walled gas bubbles, right? So that is also correct because in a thermometer, when these walls are very thick, right? When these walls are very thick, since it is glass, so in glass it doesn't conduct heat much higher. So if these walls are very high in thickness, they will not conduct the temperature in, or it will take more time to conduct the heat into the mercury, right? So the wall should be thin enough to quickly conduct the temperature from the object that we are measuring to the mercury liquid, right? So that is also correct. The next one is by using a mercury glass thermometer with a large mercury bulb, the range of measurement can be increased. So that one will be the wrong one, guys, because if you increase the amount of the mercury in the bulb, it will not affect to the range. Of course, it will increase the sensitivity, but it will not increase the range because the range is defined according to the boiling point of the mercury, because when the temperature is higher than the boiling point, this liquid is actually boil. So there will be no any changes in the range. It will change the sensitivity, so that will be the wrong one. Of course, we'll see other two also. Two different types of thermometer may give slightly different reading at the same temperature, as all thermometric properties are not equally sensitive. So that is simple one. You know that if the sensitivity is different, two thermometers will give slightly different temperature changes, right? And the next one is having a large contact angle between mercury and glass is advantage for accurate reading in mercury. Yes, that is correct, because mercury doesn't stick with the glass, right? So it will stay like this, right? So water, you know, water sticks with the glass, right? Water sticks with the glass, so it will have a force upward, right? So the water will stick with the glass. So there, if the liquid is getting stuck in the bulb, it will not show a accurate reading. But mercury doesn't stick with it because the angle is very high, right? So that is the reason. So that statement also correct. So the wrong one is the third one. So the next question is, considering the following statement regarding the physics properties of ultraviolet and ultrasound waves, right? So the first one is, energy of both wave depends on their frequency. That is wrong, guys, because the energy of a ultraviolet wave doesn't depend on the frequency. Of course, the ultraviolet waves depends on the frequency, right? So the second one is, both waves have the ability to ionize the materials. No, because ultrasound is not an electromagnetic wave, right? It needs a medium to pass through. Meanwhile, the ultraviolet waves doesn't need a medium to pass through because it is a electromagnetic wave, right? So the second one is also wrong because ultraviolet doesn't ionize the material, and also both wave can be polarized. So that is also wrong, guys, because uh, as I said, ultraviolet is not an electromagnetic wave, so it can't polarize. Polarizing wave will be ultraviolet wave, because ultraviolet and X wave and gamma waves, those will polarize because they are high frequency electromagnetic waves, right? So all three statements are wrong, so the answer will be the fifth one. So the next question is, an object is moving in a circular path at a constant speed v as shown in the figure. The change in the velocity of the object when moving from A to B is, right? So the velocity, you know, it is a vector, so it does have the direction and also the magnitude. So in these kind of situations, you should consider uh, a diagram, and you should find your answer, right? So if they are asking about speed, speed is not a vector, so there is no any direction. You can directly say that by minusing the magnitude. But in case of velocity, it's a vector, so you should consider the directions as well, right? So as they have said, it is initially at A, right? Traveling at a velocity of v, right? And it's coming to this point B, which is perpendicular at a velocity of v, right? So these kind of situations, to measure the velocity change, right? Velocity change, you know, the relative velocity equation is vb minus va, right? The final one minus the initial stage, right? So the final one, you know, it is in this direction with v magnitude, right? Minus the initial one in this direction with v velocity. So as you know, which means you should know at this stage, v, you can change the direction by adding a minus. So that minus will multiply with this minus, and it become eventually it will become a plus. So I can mark its plus v in this direction, right? So when you have two velocities in perpendicular directions, you know that you can find it like this: v in upper direction and then v in this direction with same magnitude. So the ultimate velocity will be in this direction, right? So as you know, since these both are equal sides in a triangle, this will be 45 degrees, right? And the magnitude will be root 2 v, right? So according to the Pythagoras theorem, you can verify that it will be root 2 v in 45-degree angle at the mentioned direction, right? So the answer will be fourth one. So the next question, weightlifter lifts a weight vertically up, right, in positive direction. So they are considering the upward direction is the positive direction. So I am going to mark that at this point, right? With his hands, the sign of the work done, right? done by. They are asking for the work done by for three statements. One is his hands on the weight, and the other one is gravity on the weight, and the weight on his hand respective are, right? So we are going to consider first by his hand to the weight, right? So they have said the weight is lift by his hand, which means this is the displacement is in upper direction, right? So I'll just mark it as h, right? And also the force also given in upper direction, because when you are lifting an object, you are giving the force upwards to that object, right? So here you can see that both are in upward, which means the plus, right? So force is also in plus direction and displacement also in plus direction, so it will be eventually in plus, right? So the next one is by the gravity on the weight, right? So in a weight, you know that gravity always acts perpendicularly downwards, right? But the deflection or the displacement is in upper direction, right? So since I am considering that vertically upwards is plus, right? Mg, the force will be in minus direction, and h will be in plus direction, so eventually it will be in minus direction, right? And the final one is by the weight on his hand, right? So here guys, they are considering not about the weight but the force in hand, right? So if the weight is if the hand is giving the weight force in upper direction, right? You know, by Newton's third law, the weight will give a same magnitude force in the opposite direction to the hand, right? Okay. But the hand and weight also both moving in upper direction. So here you know, as a fundamental rule, F is in minus direction, H is in plus direction. So ultimately it will be in minus direction, right? So referring to this, you can check the answers, right? So the answer will be the third one, plus, minus, and minus, right? So the next question, considering the following statement regarding the level, regarding a three-level laser system having energies E1, E2, and E3. So E1, the energy of E1 is smaller than E2, and energy of E2 is smaller than E3, right? As shown in the figure. So guys, these are the three energy levels, right? E1, E2, and E3, right? E1, E2, and E3, right? So they are saying that laser action is happening between these three energy levels, right? So the first statement is the laser action occurs between energy level 2 and 1, right? Okay, guys, you know that the laser will be occurring between E2 and E1 because this is the metastable state, right? This is the metastable state, and you know this goes up, right? Doesn't resist much long time, so it quickly comes to the metastable, and most of the particles will be here, some particles will be here. So the population inversion is happening between E1 and E2, so the laser action will eventually occur between E1 and E2, right? So that statement is correct. So the B statement, the frequency of pumping radiation is E3 minus E2 over H. Okay, so that is wrong because the pumping radiation equation will be E3 minus E1 over H. We are considering this distance as H, right? So this is the lowest one, this is the highest one. So the pumping radiation equation will be this, right? So that second statement is wrong. The third one, level 3 is known as the metastable energy level. Okay, that is correct, guys, because I already mentioned that the E2 is metastable. So as you know, the particle will go up and doesn't resist higher at this point, so it will quickly come back to the metastable, so it will resist more respective to other levels. So this is called as the metastable energy level. So that statement is wrong because they are saying level 3 is known as the metastable energy level. No, level 2 is known as metastable energy level, right? So only the A is correct, so the answer will be the first one. So that's it, guys, for this video. So we are going to talk about this paper continuously through our future videos. from 1 to 50, and also the structure and the essay part. So keep in touch with the channel. You can subscribe and you can click on the bell button to get your notifications as soon as possible, so you can continue with the lesson frequently with us.